Hello and welcome. In this lecture, we are going to look at for loop. So, under the repetition construct in programming, we have the for loop, the while loop, and then the do while loop. Now, here we are going to focus on the for loop and how we can use it. Basically, for loop are used for printing numbers. Now, it can be used for other things, but for now, I want you to understand that if it's about for loop, then we are looking at how we can print numbers. Okay, now this concept is borrowed from devices like the printer. You can just give some command to the printer, like maybe 14, and then when you press print, automatically it's going to generate 14 document, or it's going to print out 14 document. So that is something similar with the for loop. It's used for printing numbers, something like that. Okay, understanding this will help you to be able to work around arrays. Okay, so this is the structure. We start with the for keyword, and then we call it initial. That's the first thing. Condition, and then the step. Initial, condition, and then the step. Okay, now we know that for loop is used for counting. That is what we have in mind. It's used for counting. Now here is it. Let's say we are asked to print from 10. Okay, let me make it 1 to 10. That's the task. So printing from 1 to 10, the question you ask yourself is, where should we start from? It's clearly indicated that we are supposed to start from 1, right? So therefore, with a for loop construct, the variable, the number you are starting the counting from will come first here. Okay, and if it's 1 is simply an integer. So we say int I is equal to 1. Now, why do we have I here? We know the structure for creating variable, that right after the data type, the next thing that comes is the identifier. So it's just the identifier. It's not supposed to be only I. It can be any identifier you want. Okay, but we choose to go with I because it stands for what? The initial. That's the starting point of this our counting. Okay, but you are free to use any name you want. Some use index, some too can use J, K. It can be anything, but let me go with I. So it stands for initial. So we want to start the counting from I, and then you can see right after that our semicolon is what? Applied. We move on to the next thing. Now, following the previous lecture, when we say conditions, it's all about having the comparison operator in use, and then getting an outcome of either true or false. Okay, so if this is your first time watching our video, try and then go back to the previous ones where we talked about operators. I think programming methods. Check the programming methods playlist, and then go to conditions to learn how conditions can be constructed in programming. Okay, so our condition will be that the I is less than or equal to 10. Okay, now this is very important. Now you can jot this thing down in your notes, that for loops, okay, they only run or they only execute as far as the condition is what is true. You know what, let me finish the construct and I'll explain it very well for you. So I plus plus, let me make it I plus equals 1. Okay, so we are saying that we are starting the count from 1, and then we have a condition that states that this I here, it can keep printing, but the end of it should be 10. So as far as the I is less than or equal to 10, that is where the condition should be true. The moment it goes down, that means it can't, it will not be satisfied. So the moment it goes be above, so if the I is equal to 11 or something, it will not work. Okay, we will look at this very well again. And then the step you see here, I plus equals 1, means keep adding 1 1 1 to each step of iteration. So watch this. See out I. Now here we are trying to display I. We'll run the program now, and you can see if you see on the screen, you can see we have from 1 all the way to what? All the way to 10, 1 to 10. Okay, now how was it possible? Okay, so this is it. Please pay attention here. Now we stated that we want the I to start from what? From 1. And then we have a condition that states that the I is less than or equal to 10, and then I plus equals 1. In programming, the plus equals, we call it the addition assignment, and this is coming from the assignment operators. Okay, it means whatever the value of 1 is, just add another 1 to it. So the I plus plus will always add 1 1 1 to the I to make sure the I keeps what? Increasing. That is the job of the I, of the step. Okay, so when we start the program, I is equated to 1. Okay, that's the first thing. It will check this to know where it should start from. Then right after this is done, it will go ahead and then check the condition. So for the first time, wherever we see I, we know I is what? I is 1. So let's substitute I here and see if the condition here will return true or false. So is I less than, that is the 1, is 1 less than or equal to 10? That is true. 1 is less than or equal to 10. So since that is true, the program will jump and then what? Come to the displaying side. It checks this one, checks the condition, and then do the displaying. Okay, so right after doing the displaying, it was what? 1. So it will display the 1 here. Now, since the condition returned true, the loop will always keep running. So over here it was true. It came down to display the 1. Now it have to come and then check the condition again. That's how loops are supposed to work. If the condition is true, they keep working, they keep executing, they keep running. That is it. So since it was true, it will not come to the step. It will come and then display the value of I, which is what? 1. That's why I can see the 1 is here. And then right after it's done displaying, it will come to do the checking again. But before coming to check, the step of the plus equals 1 will be applied. Okay, the step of the plus equals 1 will be applied, and then the plus equals 1 always add 1 to the value of I. So it was 1 that was displayed. Now coming back to check again, the plus equals, the step of 1 will be added, making the I what? 2. You get it? So this side will just increase the value of the I by adding 1 to it, making it 2. So now that is 2, the program will come back again to do the checking. But it's not the, we already have I to be 2. It will not come here again to come and then set it to 1 again. It will jump straight forward to the condition. So as for the int I equals 1, it only take note of it for the first time, and right after it's done seeing or knowing that the I is 1, the next time it runs, it goes straight to check the condition. So now the I is 2. You put 2 here. 2, is it either less than or equal to 10? And I think it's true because 2 is less than 10. So that means the whole condition here is what? Returning true. Because the condition is returning true, the loop will come and then execute. So it will just display 2 here because of the command we have here. So it will display the 2, and then coming to run again, the step of the plus equals 1 will also come in. So this one will change it from being 2 to what? To 3. Now we come again. 3. Is 3 less than or equal to 10? That is also true. So since the 3 is less than or equal to 10, the loop will just go straight to the body and then display the 3 straightforward. So right whenever the condition is true, the loop will not check the step. it will go straight and then display the value it performed the check on. So since it's less than 3, 3 is less than the 10, it will come straight to display the 3. And then right after going to check the condition again, this step will come in, or you just add 1 to it, making it 4. So since the step is adding 1 to it, coming back again to check it is going to be what? 4. So 4, is it less than or equal to 10? Yes, we know 4 is less than 10. So it will just come inside and then what? Display the 4. After the moment is done displaying the 4, the step also comes in again, and then the step will add 1 to the 4, making it 5. Then it jumps straight forward. You get it? So it's going to continue like that. So it gets to 11. When it gets to 11, it gets to this particular side. 11 will never be greater than 11 will never be less than or equal to 10. So the moment it gets to 11, the condition here will not pass, it will fail. So it will not even execute or display the 11 as part of the output. Okay, so that's the structure. For the first time, the loop will check the initial. Okay, but after the first time it runs, it will not check the initial again. It will always be checking the condition, and then the step will be applying. Okay, all right, let me keep this very short so that you understand. Now, instead of printing from 1 to 10, I want to make it 1 to 3. 1 to 3. Okay, so we have a new application here now. Let me execute. So run the program, and you can see we have from 1 to 3. So again, let me explain. When the application start, the I is set to 1. So this tells the loop that our counting should start from 1 and then should end at whatever condition we give to it. Now, right after seeing or knowing where it should start, it goes on to the next one, being the condition. So I is less than or equal to 3. That's the condition, and then that's the step. Okay, now I is 1. We substitute the 1 here. 1 is 1 less than or equal to 3. So the 1 is less than 3. So this condition here will be what? Will be true. So since the condition is true, the loop will come and then display the 1 here. So that will be the command. It will display the 1. And the condition returned true. Now, whenever the condition returned true, like I said, the loop will always keep running. So because it returned true, it will come back again to check. But right before it comes again to check, that is where the step is applied. So it's 1 and it has displayed the 1. Going back, the step will be applied, making it what? 2. Now let's come here again. It will not work with this side again. It will just come here straightforward for the second time. This is only for the first time check. Now 2. So 2 is 2 less than or equal to 3. Yes, 2 is less than 3. So as a result, it's going to display the 2, and then coming to check the condition again, the step will be what? Applied. So the step will be applied, making it what? 3. You come back to check. Is 3 less than or equal to 3? So 3 is not less than, but it's also equal to 3. So this condition again will return what? True. So it's going to display the 3 here, and then right after it's done displaying the 3, the step of 1 will be applied. So it's going to add 1 to the value, that is 3, making it 4. Then it goes straight to check the condition. So here will be 4. Now substituting 4 here, is it going to be true or false? Is 4 less than or equal to 3? That is false. So the moment the condition here returns false, then it's going to be a dead end for the loop. The loop is then going to stop running or stop executing. So that will be the end of the loop. Okay, that will be the end of the loop. So as your assignment, I want you to use the for loop and then display from 3 all the way to 1. Display from 3 to 1. So you can pause the video and then do that. When you finish, you can resume to look at the solution. Okay, all right. So I'm assuming maybe you are done. To display from 3 all the way to 1, we just have to change it and tell the loop that the initial, that's the starting, we want it to be what? We want it to be 3. And then the condition, we say that, the I is greater than or equal to 1. And then the step, we make it minus. Let's see what will happen. So you can see we have 3, 2, 1. Okay. Now look at what is happening here. Now with the 3, 2, 1, the I is set to 3, and then this is the condition. So like I said, it will always keep checking a condition. When it starts, I should be greater than or equal to 1, and starting is 3, so 3 is greater than 1. This condition is true. It will come here and then display the 3. Before going to check the condition again, there is I minus equals 1. That is responsible for, deducting 1 from the I. So because of this step you see here, it's going to take 1 from the 3, making it what? 2. Okay. Then it asks again, is 2 greater than or equal to 1? Yes. 2 is greater than 1. So it will come and then display the 2 here. Coming to check the condition, the deduction will happen, making it 1. Then it goes again. Is 1 greater than or equal to 1? Yes. 1 is equal to 1. So it's also true. It will display the 1 here. And then the deduction will happen, making it what? 0. Then it comes again. Is 0 greater than or equal to 1? That is false. 0 can never be greater than or equal to 1. So as a result, the loop is going to what? Is going to end. And that will be the full stop for the loop. So this is the structure for the for loop. We have the initial, we have the condition, and then we have the what? We have the step. Now you are free to put any step here. Okay. If you put minus equals, it means the loop is going to be deducting 1, 1, 1 from it. And most of the time, over here it becomes minus only when you are reversing a particular count. So instead of going ascending, you want to go descending. That is where it becomes minus. Okay, you need to check this very well. Now there are some circumstances, or there are some instances where your loop will stop will never fail. As for loops, they are configured to run, and the moment they stop running, that is where it ends, and it will stop running based on a condition. But sometimes failing to give the proper condition and then a proper step to your loop can make the loop run forever. Now this is one of the critical issues. We call it infinite loop. So infinite loop is the situation where your condition is never failing. Number one, keep in mind that loops are always supposed to execute. Now for them, they run based on condition. So if for 3 years your condition is not failing, the loop will keep running until the particular condition is met. Now the situation whereby your condition is not failing, it will trigger the loop to run on forever without stopping, and that is what we call the infinite loop. Now watch this. Suppose instead of here being negative, I make it positive. So at each iteration count, whenever it checks the condition and then display and then coming to check again, that is what we call the iteration count. So for each iteration count, there's going to be an addition of 1 to the value of I. So it will start from 3, display the 3, coming to check again. Because of the plus equals 1, is going to be adding 1, 1, 1, 1 to the I. Meaning there's no way the condition will fail. Wait, let's check something here. So yes. So you see these numbers increasing. They will never stop. Now it will keep printing the numbers forever because the condition is never failing, or it's never seen any reason to fail. You get it? For each of the iteration count is adding 1, 1 to it. And as the values increase from 3 upwards, they are always greater than 1. So the condition will never fail. This one, when you leave it for a very long time, it can crash your PC. So it's something you should run away from. Each time you run your program and you realize you are getting something like this, it's a problem. We call it infinite loop, and this kind of issue can worry your PC. It's something you should avoid. Now, how can you fix these errors, or how can you find your way around? Number one is to make sure you have the proper condition, and then you have your correct step. Most of the time it's the step that does that, so make sure your step and then your condition are properly formed. Again, another issue that can make your day bad is the situation where your loop is not running at all. Sometimes you can have your loop, you execute it, and you can see no counting. We are trying to get from 3 to 1, but then you can see it doesn't work. If your loop is not working, the first thing to check is the step and then the condition. Okay, now we have stated that we want the I to start from 0, and this I that you want to start from 0, look at the condition. We are saying that the I is greater than or equal to 1. So for the first time, we substitute 0 here. Is 0 either greater or equal to 1? That is false. So the moment the condition here is false, the loop will not execute. That's going to be the end. So please keep in mind the initial, the condition, and then the step. They are very crucial. Okay, you always need the right step, the right initial, the right condition, and then the right step for your loop to work the way you expect. Okay, for your loop to work the way you expect. All right, so that is about for loop. There are some other things to look at, but I don't intend to make the video too long. We will end here for the for loop. And if you haven't subscribed to the channel, kindly try subscribing, like the video, share, and then give me your comment. Okay, thank you so much, and we will meet in the next video. Bye.